Gas laws. Here we are to study kinetic theory, but before that, as a foundation knowledge, you must be having the idea of gas laws. You see, the Bayes law, P proportional to 1 upon V, and Charles law, V proportional to T. What is T here? Absolute temperature. What does it ultimately conclude? When you consider T0, it gives V equal to 0, and 0 volume means no existence. Means it says at 0 Kelvin, the volume of the gases will cease to be, that will not exist. It means gas laws, conventional gas laws, Boyle's law, Charles law, pressure law, they are not in a position to define what is absolute 0. As a second step to this, there was introduction of kinetic theory. Kinetic theory was basically introduced by the cooperation of a panel of physicists, but the basic credit goes to Bernoulli. He is known as father of kinetic theory. This theory is a set of postulates. Actually, it is not a principle, it is some assumption which were not explained those days. Those were assumed as a postulate and they were put together. That set of postulates was known as kinetic theory. The molecules were considered very, very small, negligible in size, means their volume was considered negligible with respect to the total volume. All the molecules are identical, their size was not considered, but they were considered, they are all identical. They used to move randomly in different direction with different velocities, and average velocity is considered 0. There is no intermolecular force. Since we had no idea, so it seems very funny that if we do know nothing, then we would say that it is not existing. So, that is the case with kinetic theory also. People or the scientists did not know what is intermolecular force. So, they said there is no intermolecular force between the molecules. They consider the molecules during their motion collide, and that collision is elastic, which means there is no loss of kinetic energy. It was also considered that when they collide, the time taken in one collision is very small compared to time taken between two successive collisions. And finally, average kinetic energy of molecule. For this kinetic energy, it was supposed that it depends only on the temperature, because we did consider that velocity depends on temperature only, and velocity is going to decide kinetic energy. That is why this assumption that translational kinetic energy of molecules depends on only temperature. And one more thing, in kinetic theory, it was assumed that whenever we put any amount of gas in a container, that will spread throughout the volume. And the explanation for this was given by saying that there is no effect of gravity on gas molecules. It was considered, and there is no intermolecular force, they simply know how to spread because of their velocity. It is not the case with the liquid. You drop few drops of water in a tank, that will go to the bottom. You allow very small quantity of the gas in a big container, that is going to spread throughout the container. For this, explanation was given in a way that there is no intermolecular force and there is no effect of gravity. Now, we are going to derive this relation for pressure on the basis of kinetic theory. One surface, the gas is enclosed within a cube or any container. On one wall, molecules go, collide and return back. See, if the velocity is Vx, it becomes minus Vx. Change in velocity minus Vx, it becomes 2Vx minus change in momentum will be minus 2mvx. This is the change in momentum of one molecule when it collides with a vertical wall. Now, suppose the width of the container is L, then L, once it collides, it will go, it will come back, distance taken will be 2L, time taken will be 2L upon V. This is the time taken in one collision. So, number of collision per second will be just reverse of it. That means, number of collision per second is going to be Vx upon 2L. You want to find the total change in momentum per second. You multiply the two, you will find, you multiply these two, you will find 2m Vx into Vx upon 2L, that is mVx square upon L. This is the change in momentum per second. Rate of change in momentum, that is called force. So, this could be written as Fx. Now, you want to find the pressure divided by area. It is going to be mVx square upon A into L, and that is nothing but volume. So, this is mVx square upon V, and this term becomes pressure itself. You got the relation but for pressure, but this is in terms of Vx. Vx square will be V square by 3, because I have told you there is uniform distribution of gas molecules. They have the equal possibility of movement along all the 3 axes. So, if you consider the average, this will also be average. It could be replaced by V square by 3. This is m V square by 3 V. But you see, so far you have considered only one molecule. If you consider n molecules, obviously because of all, this is going to be mn V square. This is the relation for pressure, a very important relation that has been derived on the basis of kinetic theory, rather the postulates of kinetic theory. It is the pressure for the gas. M into N becomes the total mass of the gas. Total mass divided by the volume, it is going to be density. So, this could be written as 1 by 3 dB square. This is another relation, at another relation for pressure in terms of density. I have chosen this symbol rho in place of d, but d here stands for density.